For example 1b, we are going to graph y equals the negative 0.75 cosine of pi over 2x. Now the first things that we need to figure out are the period and the amplitude for this cosine function. And let's start off with the amplitude. The amplitude is determined by this number out front. And that number in front, we have an amplitude of 0.75. So remember, that's telling us our distance from the middle to the top and the middle to the bottom. Now for all of these ones, again, we're not doing any translations up and down, so our midline is going to be at 0. That negative is just our clue that, hey, we have this reflection in there. So I'm going to make that note down here too, that we have a reflection, just so we don't forget when we go to graph. And then we also have to figure out the period of our function here. And the period, remember, we find by taking 2 pi divided by b. And b is that number that's in front of the x in our equation. In this case, that number in front of the x is kind of messy because it's pi over 2. So 2 pi divided by pi over 2. And instead of writing it as a fraction over a fraction, I'm going to write this way. This will make it a little bit easier as we keep going forward. So 2 pi divided by our number in front is going to give us the period. We're dividing by a fraction though. So remember that the way we divide fractions is multiplying by the reciprocal. So I really want to take 2 pi times 2 over pi. We reciprocate that fraction, we flip it. And when we multiply, we'd get 4 pi over pi, because this is really 2 pi over 1. So multiply the tops, that's 4 pi, multiply the bottoms is pi. Those pi's cancel out, the period is just 4. So let's start our graph. Let's look at what we have here. I'm going to draw my x-axis and my y-axis. We know the period is 4, so out a little ways, that's the period. Keep in mind with our sine and cosine functions, all of our key features, all of our key points happen at these quarter points. Okay, so halfway through, and then 1/4 of the way through, and 3/4 of the way through are all of our major points. That's our x-intercepts, that's our maximums and our minimums. And that's the same idea here. So we split our graph into fourths, in half, and then each half in half. And then we have to figure out what this is going to go up by. And this one is actually pretty easy because half of 4 is 2. And then we have 1 and 3 in the middle. We're going up by 1s each step of the way. Remember that trick though, that we can take our period times the 4th to figure out what we go up by. We're going up by 1s here. So 1, 2, 3, and 4. And then to finish off our graph, we figured out our amplitude is 0.75. That's the highest we're going to go. And also the lowest will go, negative 0.75. The last step is to fill in our graph the rest of the way. And we have a cosine function here. So let's look at what the regular cosine graph looks like. The regular cosine, we start at the highest point. We go high, middle, low, middle, high. In this case, though, we have that negative. We have this reflection. So our graph, instead of starting at the highest point, we are going to start at the lowest point and go up. Starting at our lowest point is down here, and then we'll go up low, middle, high, middle, low, and that is going to complete a cycle of our graph. That's going to complete one period. And we just want to make sure for cosine functions that we kind of curve the ends back up and don't just put arrows on the ends here, like at this negative 0.75 and at the the 4 here because we don't want to make our graph look like it keeps going down. We want to make sure that we show, hey, it's going to come back up and repeat. But that's what our graph is going to look like.